I'm going to talk to you about how to use scale to either help you find the actual size of an object, or to find the model size of an object, or to find the actual distance or size, or the actual distance between two cities or two places, or the distance on the map. Um, what I want you to realize is that scale is a ratio, which is a comparison of two numbers. So when I see 1 to 4, there is a ratio because I'm comparing two numbers. But because it's scale that we're talking about, the first number stands for model, and the second number stands for actual. And because there's no units here, it can be any unit, but they're the same unit because there's not a unit here, meaning this could be 1 inch to 4 inch, it could be 1 inch to 1 mile, it could be 1 millimeter to 4 millimeters. But what this means, if you see a ratio of 1 to 4 or a scale of 1 to 4, that means if it's 1 unit on the model, it's 4 units on the actual. So the actual item is 4 times larger than what you see in the model. And models can be maps, they can be scale drawings, they can be pictures. A globe is an example of a model. Maps are models. Toy cars like Hot Wheels or Matchbox cars, those are models. Um, Something you see on a microscope, that is a model of something real. Um, but just remember, it's always model to actual. And it can go the other way. Like a 1 to 4 means if the model is 1 inch, the actual is 4 inches, the model is reduced from the actual item because the actual item is 4 times larger than the model. So the model is a reduction of the real item. But it goes the other way around. If you see a scale of 5 to 1, that means on the model, if it's 5 units, the actual unit is, and the actual item is 1 unit. So you're going from from a 1 unit to a 5 unit, you've enlarged the item. And some examples of enlarging would be like an eye. If you're at the eye doctor and you see a model of an eyeball and it's big, it's 5 times larger than the eyeball, that's enlarged from the item. When you look at something in a microscope, it's enlarged because things that you look at in the microscope are really, really small, but they're enlarged so that you can see the detail. Okay, so I'm going to show you a couple of examples, but I want you to remember that everything we're going to use is model to actual, okay? So, so this first example right here, it says, on a biology poster, a beetle is drawn to the scale of 9 centimeters to 2 centimeters. That's the model is 9 centimeters, whereas in actuality, it's only 2 centimeters long. If the drawing on the poster is 28 centimeters long, how long is the actual beetle? So again, I'm going to go ahead and write model to actual. And writing this out, it sounds like it's a waste of time to actually do this, but it's kind of like writing out PEMDAS whenever you're solving an order of operations problem. It just helps you keep everything straight, okay? And so for this particular problem, the scale was given 9 centimeters to 2 centimeters. So I'm going to write 9 centimeters to 2 centimeters. If the drawing on the poster, and the model here is the drawing, this drawing, that's our model, okay? So if the drawing on the poster is 28 centimeters, how long is the actual beetle? And so you can see here we're figuring out the actual, so that's why we're going to put our X underneath the actual. So 9 centimeters on the model is 2 centimeters actually, so if it's 28 centimeters on the model, how big is it actually? And when I get to this point, I can see that I have what looks like a proportion. So you've got 9 over 28 equals 2 over x. Well, I can use this to help me solve the problem. I can cross multiply and divide. So I'm going to say 9 times x is 9x. And then I'm going to say 28 times 2 is 56. I am going to solve this by dividing both sides by 9. That all cancels out, and I have x equals 56 divided by 9. Well, when I divide 56 by 9, it goes in 6 times with a remainder of 2. So it is 6 2/9. So that means it is 6 2/9 centimeters long in real life if it's 28 centimeters long on the poster. If the directions aren't specific about a fraction or a decimal, you can give it either way. So as a fraction, this is 6 2/9. As a decimal, it would be 6.2 repeating, or you could round it to the nearest hundredth. It would be 6.22. It just depends on your preference, or unless, like I said, unless the directions are specific otherwise, okay? So the next example I'm going to show you, in this example, I'm sorry, we were enlarging. The model is a larger version of the actual item. I'm going to give you an example of where it's reduced, okay? If the scale used on a map is 1 inch to 50 miles, so that's the scale it's already given, model to actual, the model is 1 inch, it's actually 50 miles, so you can see where we've shrunk what's actually 50 miles, we've reduced it down to 1 inch. And it is 3 inches between Atlanta and Macon. How many miles is between the two cities? So again, we're going to do model to actual, and I'm going to write it out just to help me keep everything straight. And when I do that, I can then fill in the rest. So I'm going to say 1 inch to 50 miles. And it's 3 inches between Atlanta and Macon. So the 3 inches represents the model, not the actual. So I'm going to do 3 inches. And if you're not sure, look at your unit. You want your units to line up. So the unit can be used as another hint to help you decide, well, I'm not going to put it over here because then I'd have miles over inches. So remember, with proportions or with scale, you want to be consistent. So I'm going to say 3 inch, and it says what is the actual distance, or how many miles are really between the two cities. That means that's my X right there. So then again, here you have the proportion, and I'm going to cross multiply. 50 times 3 is 150, and then 1 times X is X. So that it means that this is 100, that it is really 150 miles between Atlanta and Macon. And don't go with me on that, or trust me on that exactly. I just kind of made up those numbers. That doesn't mean that's exactly how